Next episode on quantum mechanics. I've got a 30-minute drive. Well, may you ask, how's he got time to do these things, Hasn't he got a job? Well, yeah. But you go for drives, don't you? What do you do on your drives? And don't you think it's disgusting when someone eats a mandarin? Yeah, on camera? That's just a lack of respect, that is. All right then. I just slot it in. All right. Now, I want to talk about something, and I've got a vague idea about what that is. And this is my second quantum mechanics episode today. I made one on the way to Dandenong, and now I'm making one on the way back. Now I want to talk. I want to yak about something, and I thought to myself, I'm going to talk about this business that I've been hearing about in physics, to do with the wave nature of particles. Take like a bullet. When you fire a bullet out of a gun, that's a particle. It's a thing. But it's got a wave nature too. But because a bullet is so huge compared to something very, very small like an electron, just one electron, because a bullet is so huge, massively huge, its wave-like nature is nigh on undetectable. And someone like me, I'm even bigger than a bullet. I'm a particle sitting here in the car. My car's a particle too, driving along the road. The wavelength, we're a little bit like a wave and a little bit like a particle at the same time. That's just a reality, and it's been proven. You can say, no, that's not true because I can't see it. Well, other people have seen it. It's all written up. They haven't seen it with their own eyes, this wave-like nature of particles, because the particles that you can observe this thing with are so small that you can't see it with the human eye, but we can make instruments that can see it. So that's another way of seeing it. What do you mean by seeing it? It doesn't have to be with your own eyes. In fact, sometimes your own eyes can deceive you more than an instrument can. Sometimes you can trust something you can see with an instrument better than you can trust something with your own eyes. So, don't discount. Don't think that only things that your eyes can see that you'll trust. There you go. You can see things with other things. And that's it. So we can detect electrons, for example, in an atom, so we can see them. It's kind of see them. We don't see them, but we see evidence of them, and that's a way of seeing them. Concrete evidence. Nice mandarin. If I respected you, I would be eating in front of you. All right. So I wanted to talk about this business of just the fact that particles, like a bullet or me or an electron, are particles, but they have a wave-like nature. They're like a wave as well. A wave in a lake. They've got a property like that as well, and that's what quantum mechanics is all about. The fact that it's a bit like a particle and a bit like a wave. Everything, even me, even my car, even the Earth. The Earth's got a huge wavelength. It's a particle, but it's got a huge wavelength. I wonder if the wavelength of the Earth is 55,000 light years. I wonder if the wavelength of the Earth is so big that it's bigger than the diameter of the universe. Wouldn't have a clue. I'm sure someone could do the calculations. I bet you it's very big. But electrons have a very small wavelength. I was going to say short. Yeah, all right, a short wavelength. So short so short that it's the way it acts. It conforms with the way a wave should act. You know, like its particle-like nature, which is the particle nature, you know, the solid nature of a big thing like a bullet or a human or a car or the earth is so dominant you can't see its wave-like nature. But when you go into the very, very small, the wave nature starts to dominate a little bit, and become just as significant as the particle-like nature of the thing. So you start to really see us for what we are. You start to see me for who I am. If you actually dig in and just have a look at one electron inside me, you know, one particle inside me, you start to say, oh, you're made up of those things. You're just a big bunch of waves, aren't you, really? But it's an interesting thing, being a wave, as well as a physical thing, as I am. You know, I'm just a big wave. You know, I'm just a waving. I'm cruising along down the freeway here, heading for Essendon, but I'm like a whole lot of wavy things inside, you know. And my whole car is just a whole lot of particles, which are all wavy in nature. You know, I don't even feel solid. I feel like my car and me are just like millions and billions and trillions and quadrillions of little tiny wavy things. You know, if you drew it, it'd be little wavy things cruising on down the freeway. You know, and this is, you know. Anyway, so that's that. I don't even feel solid. But it depends on your definition of solid. I feel solid because I define solid as something that can do this to my window. So now that was wavy things banging into other wavy things. You know, my hand banging into the window. And they're both wavy things. But given that they made that sound, I'll say, all right, well, may they be wavy things, but they made that sound. And I'm going to define the word solid to mean anything that makes that sound. There you go. So I got a definition of the word solid. All right. Now it's solid. All right. It's only things often come down to the definition. They often don't come down to whether something's true or not. You know, it all comes down to how you define your words as to whether something is true or not. All right. You know, so someone might come to me and say, "You're not solid. You're just an energy in the universe." You know, hippies sort of say that. You're not actually solid. You're a hippie. No, I am actually. You're just a whole bunch of waves. So you're not actually solid. I say, yeah, but what if I define the word solid to mean anything that makes a bang? Anything that can make a bang? Then I'm solid whether I'm a wave or not. And anyway, I'm not only a wave, no matter how hippie you want to be. You know, because hippies say that, you're just energy. You're just energy. I say, no, I'm not. I'm not just energy. I'm full of particles as well, which happen to have a wave-like nature as well, and which happen to carry energy as well. But I'm not just energy. You know, I'm not just energy. I'm pretty sure I carry energy. You know, I actually think I'm full of particles and waves, which actually are able to, you know, move energy around. I don't think I am energy. You know, I think I'm one great big fat particle which has a wave-like nature, and waves carry energy. So I am, nouns, verbs, whatever, I'm not energy. I'm particles and I'm waves, and I carry energy. Get your grammar right. I don't even know if I've got that right. I'm making some of this stuff up as I go along. All right. You say, oh, yeah, but I define energy to be what you are. Well, that's just circular. I can call myself a cat. I can define a cat to be what I am, and then say, and now, therefore, I am a cat, because I just proved it, because I just defined a cat to be what I am. That's just stupid. You can't do that. That's a stupid game. You can't just say I am energy because you define me to be energy, therefore I am energy. That's just, what are you doing? You can't even talk if you're going to do that. All right. But anyway, so bottom line, the jury is in, and we are, we are a bunch of particles. And those particles have a wave-like nature, or we are a bunch of waves, and those waves have a particle-like nature. Choose your poison, and but to really kind of understand how that can be, you wouldn't look at me, because sure, I've got a particle-like nature, I'm a solid thing, but it's really hard to spot my wave-like nature, unless you ask a bloody hippie and says, oh, it's just him, just see through. No, you can't. You can't measure my wavelength, it's too big, You can't measure my frequency, Oh, you're part of the frequency of the universe. Well, yeah, but I'm also a particle, And I'm not a frequency, I've got a frequency. Get your grammar right. The universe is made up of frequencies. No, it's not. It's made up of waves which have a frequency. Yeah, it might be semantics, but I think it matters because people speak a lot of shit. All right, now, if you get your grammar wrong, it kind of distorts what you're trying to say. Like you can choose to get your grammar wrong, but if you do, you're kind of distorting. You're kind of lying by distortion. So you shouldn't do it. All right. So, look, if you really want to discover anything about my wave-like nature, in addition to my particle-like nature, my particle-like nature. If you were playing footy against me, I'm pretty good at the hip and shoulder. And if I hip and shoulder you, you'll find out that I'm fairly solid. So, it's not hard to sort of detect my solid-like nature, my particle-like nature. It's not hard to detect that. But if you really want to know about my wave-like nature, don't look at the whole of me. Just go right down deep into me, down to one of the particles in me, and just grab one of those. And if you grab one of those, have a look at how that's behaving, and then extrapolate that and say, the whole of him is like that, except 17 quadrillion times, Okay, I get it. So do it. So go right into my wherever, my brain, and grab a particle out of there. I can spare a few. I won't say whether it's an electron or, there might even be some, other sorts of particles. There's lots of different particles. A photon of light is a particle. But anyway, it doesn't matter what particle you pick, Let's pick an electron because that's easy. And pull that electron out of me and put it in a box. People can do that. Right. So you got a free electron and it's sitting in a box. Study that and you'll get a bit of an idea of what I'm all about. Okay, we're going to study that electron in that box now. Now that electron is so small physically that it has, its wave nature, its waviness, will be demonstrated by it. It will perform for you. It will behave in a wave-like way. it'll also behave for you in a particle-like way. So, you know, at one and the same time, it'll act like if let's say you shot it out of a gun. You know, you had a special gun that could fire electrons. Boom. Those things have been invented. But let's say you had a gun that could fire a single electron. All right, as you shot that thing out, it would fire out of there and it would be just like a bullet in some ways, but it would also be just like a wave. And that's what makes it different from a bullet. Because when we shoot a bullet out of a gun, it really just acts like a particle. It just acts like a solid thing. It really doesn't act like a wave thing because its wavelength is so huge we can't even see it, measure it, anything. It's just too huge, you know. Really hard to see its wave-like nature. However, this electron, when you shoot that out of an electron gun, you can see, not with your naked eye, but with instruments, you can see its wave-like nature, and that gets very interesting. You say, oh, now this guy, you know, Charlie here, he's made up of particles, so all his particles must be like that, you know. Is that how he becomes a wave, you know what I mean? But all those waves must be kind of stuck together, you know, in molecules and all that sort of stuff, such that they can't kind of escape and play. They can't play wave games as easily because they're so tightly bound to each other and into great big mega molecules and a great big mega organism like a human. And we just, you know, the wave-like nature of all the particles is obscured by the fact that they're all bound in a lattice called a human. You know, this really big extended lattice framework construction called a human, you know. All right, so that's that. All right. But anyway, we've got this electron and we've got an electron gun. Now that starts to become interesting because now here's what I heard. I think I've heard it before, but I was just listening to an audiobook today. How do you know, let's say you wanted to check out the wavelength, you know, you've been told that this electron has got a waviness. Let's say you wanted to see evidence of that. How would you do it? You might be one of those people who say, I don't believe it. I don't believe it even has a wave-like nature, so blah, blah, blah. Then get off this, you know, YouTube. Look, it's been proven. If it hasn't been proven to your satisfaction, it's just because you haven't written up books, you know. That's all right. And if you don't want to believe it, and also you don't want to read any books about it, then that's okay. Go back to the footy. You know, because, you know, if you're, without even doing the experiments yourself, you can sort of say, look, enough really smart people in the world believe it. I'm going to believe it too. It would, you know, I'd have to go and do a degree in physics and then a whole lot of extra study to sort of figure out why they believe it. But I know that it seems like everyone who's done the study believes it. That's good enough for me. It happens to be good enough for me. You know, because I actually haven't done the tests myself. I've never fired an electron out of a gun to just check for myself. But I am happy to take that on faith. And if you're not, if you have to see everything with your own eyes, go and buy an electron gun. You only need about $2 million to build a lab, you know, and 10 years to spare to study what the hell you're even studying and experimenting with. And you'll, you know, I'm happy to say that you'll find the same answer. But do you want to save yourself 10 years of effort and $2 million on building a physics lab? And still have faith, then you've come to the right place. Here we are. Okay, so I've got an electron in a box. I've got a particle in a box. And people have told me that that particle is small enough such that I'll be able to, that if I want to, I'll be able to see its wave-like nature. And that I'll also be able to see its particle-like nature. I said, oh, that's really interesting. And they said, but do it in your head because you haven't got $2 million to spare, have you? And have you got 10 years to spare? And I say, no. All right, do it in your head then. So, you know, this physicist might say to me, and so I say, I will. I'm not going to do that right now. Now, the way to check out the particle-like nature of this electron and its wave-like nature, well, there's many ways of doing that. You know, to check out its particle-like nature, you can put that electron, take it out of the box, put it in your electron gun. I know that sounds crazy, but people do that sort of thing. And you can go bang, and then you can have a certain detector, you know, like target practice. So you shoot this electron at this target over there, you know, and lo and behold, you'll see a little spot on that detector. Now that's not really going to sort of show you. That'll be good at kind of showing you its particle-like nature, because that's just like shooting a bullet and putting a hole in a target. You know, when you shoot a bullet at a target, bang, you know, and then bullet hole, right? Shooting an electron at a detector, yeah, will leave a little mark of some sort, you know, on that detector. So you go, zip, you know, and shoot that one electron at that detector. Now, but I want to see the wave-like nature of that electron, so that I can understand Charlie a little bit. I'm Charlie. So there's a way of doing that, and there's lots of ways of doing that, but here's an interesting one I heard about. You can get a piece of paper, and in that paper you can make two tiny slits with a very sharp knife, you know, so that there's two slits in the paper, and you can fire that electron through one of those slits. Now, where will that electron hit the photographic plate? Because there's a photographic plate I put on the other side of the piece of paper. Well, the funny thing is, if it was a bullet, and you got it right in the middle of one of those slits, it would just hit the piece of paper on the other side, the photographic plate on the other side. So if an electron behaved only like a particle and had no wave-like quality, if you shot it through one of those slits and went right through the middle of that slit, good shot, by the way, it would land on a photographic plate on the other side, exactly in between where it left the gun, went through the slit, and in a straight line it would hit the photographic plate on the other side. Now here's the magic thing. We've got a double slit there. I'll just do a spoiler alert. Imagine, we'll come back to that single electron in a minute. Imagine if you could, if you had a machine gun that could shoot billions of electrons at that piece of paper with the two slits on it. Or, alternatively, you could shoot billions of photons of light. Photons of light are a different type of particle, but they've also got a wavelength. They've also got a wave-like nature and a particle-like nature, just like electrons. Just take that on faith. Or spend the $2 million and do the 10-year study. But take it on faith if you don't want to. Or go and watch the footy. Now, so imagine shining a torch at this piece of paper with two slits on it, cut out of two very thin slits. Now, on the photographic plate behind tomorrow, you know, it's really late, it's midnight, it's 12:19, what? I've been watching the grand final in Dandenong. All right, now go and do this experiment yourself if you've got to spare $2 million. But, spoiler alert, if you were to shine torch at that piece of paper, just zillions of photons of light. It's like firing a massive machine gun. A torch, if you hold a torch and shine it on a piece of paper, yeah, it's like a machine gun that's just letting off so many rounds, zillions of rounds of ammunition, really fast, Anyway, a lot of those photons are going to go through one of the slits, and a lot are going to go through the other slit on the two slits in the paper, and almost all of them are just going to hit the paper. We'll forget about them. But the very few that go through, which will be only millions, maybe billions, the very few that get through, do the experiment yourself if you've got to spare $2 million and 10 years to spare. But here's the funny thing. They make a beautiful pattern, and the pattern depends on how far the slits are apart and all that sort of stuff. But the point is they make a beautiful pattern. Really weird, If the torch, all the photons were coming out like bullets, and it only had a wave-like nature, you'd really only get 2 straight lines where all the bullets went through the 2 slits, and 2 straight. Basically, all the bullets would hit the photographic plate in kind of a line. Maybe the edges of the paper would kind of just bend them a slight bit, or whatever, and interfere a little bit, and a couple would scatter, kind of hit the side of the paper and then the side of the slit, and then go off a little bit. It'd be a bit messy, but the point is you'd have 2 really dark lines, I'm sure. But in reality, if you try this experiment, and this is a spoiler alert, you just have to take it on faith. You got a problem with faith, son? There is a time for faith. And it ain't got nothing to do with Jesus. It's not that kind of faith. It's a different kind of faith. Just because, if I ask you to have faith in this thing, that doesn't open the door for you to say what the nature of God is. You said faith is okay in your thing. So faith is okay. I can believe, in QAnon. Because if you can have faith, I can have faith. It's fair. No, it's not. 2 different things. You're an idiot. Sorry, I don't mean that. Well, I do. But anyway. All right. As it turns out, believe it or not, when you shine a torch at a piece of paper like that, and zillions of photons get blocked by the paper, but millions get through those 2 slits, the particles that get through those slits hit the photographic plate on the other side, but as they do, they don't form just 2 lines. They make this amazing pattern. And the reason they make that amazing pattern, which looks beautiful, just like if people often say, if you're standing on the side of a lake and you've got 2 plastic balls and you put them in the water and you start sort of moving them up and down and making a wave, and you do it just at the right time, that's a little like the double slits. But you got double balls. I've got double balls. And you go boom, 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 like that. And you'll see that on the surface of the pond, if it's a nice still day and there's no, that you'll have a beautiful rippley effect. You'll have a wave pattern on top of the lake. Now, in exactly the same way, if you shine a torch through 2 slits like that, it'll do what the 2 balls are doing, but it'll do it with light. All the particles go through there, and they make this wonderful wave-like pattern on the photographic plate behind the 2 slits. Now, that's not actually that sort of hard to get your head around, sort of, because I think a lot of people are used to that, even ones who haven't done the 10 years study. And I haven't done the 10 years study either, and I'm happy to accept that on faith. Oh, so you're happy to accept all my arguments on QAnon? No, I'm not. And you're happy to believe that divine intervention made this universe? No, I'm not happy to take that on faith. But you took the other thing on faith? Yeah. I am. Something, I'm picky. I'm picky like that. I pick and choose. So do you. All right, but we're not equal. I'm right, you're wrong. Sorry. I may be telling the truth. Anyway, so spoiler alert, when you shine a torch on this piece of paper, as you look, afterwards, look at the photographic plate behind and you'll see this beautiful pattern. And move the slits a little bit closer to each other and the pattern will change, but it'll still be amazing. Yeah. All right then. Now, get the photographic plate, whiteboard rubber, and wipe all those spots off. Now, get a new photographic plate in, and this time, don't shine a torch on the thing. Fire one single electron through one of those slits. But remember what that pattern looked like as you do. One electron, a particle. Right. This time I've done that and I've gone bang with the electron. I could have fired a photon with a photon gun, but I fired an electron. All right, I'll use a photon gun. Keep it consistent. So you got a photon gun, I'm going to shoot one photon through one of those slits. Doesn't matter what. I'll fire a particle through one of those slits, and that one particle, this is the bit that blows my mind, knows in advance what that pattern looks like. Like it's only one particle. It already knows what that pattern is. That it knows in advance that it can only land on the photographic plate in one of the sort of areas of that photographic plate that was part of that pattern, but it will not and cannot land where the pattern wasn't. So it knows in advance where it's allowed to land on that photographic plate and where it's not. And it will land on that photographic plate in one of the spots that make up the pattern, such that it sits there waiting. It says, listen, if you're going to fire 5,000 million photons through here now, it will complete the rest of the pattern, but I'm getting the ball rolling. Now, a lot of hocus pocus, bloody Jesus loving, sorry for being insulting. Sometimes I love Jesus episodes, don't worry about it. Depends on what mood I'm in. But you'll say, oh well, if that electron or photon knew in advance where it was allowed to go and where it wasn't allowed to go, divine intervention. Because otherwise how could the electron know where it's supposed to go in advance? But the answer to that is it's got a wave-like nature before it even started. It doesn't know. Its wave-like nature is such that if the piece of paper is this distance from the photographic plate and all that sort of stuff, and it's gone through a little slit, it'll come out. It knows its own wave-like nature, I suppose, and it will land on one of the spots where that waviness would go, you know what I mean? It's not going to hop into a trough, it's going to hop onto a peak. But it doesn't know that. It just doesn't have a choice. Just like I don't, you say, but it's got a choice, hasn't it? No, it hasn't. That's exactly it. It's a little bit like saying, have I got a choice? Has the electron got a choice to be an electron in the first place? No. It just is. It hasn't got a choice. So has it got a choice in whether it has a wave-like nature such that it can't go into the troughs and it can only go onto the sort of crests of the waviness of it's where it's going to land. No, it hasn't got a choice, but only in the same way that it has got a choice about being an electron in the first place. But the point is, as it goes through that slit, that single photon of light or electron or whatever, or particle, some other sort of particle, it has no choice but to land on one of those beautiful lines that make up a future pattern. Should you ever shine a torch on a full torch beam onto that piece of paper, and it will land on one of those lines whether you do that later or not. And it almost seems magical, but it's not. It's actually just a property of the universe, like this freeway in front of me is a property of the universe. Nothing more magical than that. It's not magical. If it's magical, then this is magical. Oh, but everything is magical because it's made by God. Shut up. By definition. Yeah. All right. Okay, I'm being a bit rude tonight, aren't I? I'm not normally. But, I can never tell what I'm going to be like before I start. Now, I tried to picture in my head, because I heard all this stuff on an audiobook, what I just said. I tried to picture in my head, because I like to flip things on their head. I already flipped this one on the head, because it was whatever I described just then was described to me in a different way. Oh, by the way, that photon of light that went through the slit, it still acted like a particle when it went through, because it only landed on one spot. If it was a wave, like an ocean wave coming out of the slit, it would have landed on a lot of spots at once. Only landed on one spot. So it was a particle, but it kind of went through the slit and then went whoosh over there. It was unlikely to go over there, but it did. And if you fired another electron, it might go straight ahead. Or depending on how, and so on and so forth. You know what I mean? What was I talking about? Oh yeah, I was trying to think of, because it's hard to imagine all that. I was trying to think of a kind of analogy that helped me sort of think about how one single photon of light had no choice but to land in certain spots on the photographic plate, but not on others. And not only that, certain spots that would, if you were to shine many such particles, photons, through a slit, that they would all make a beautiful pattern. I was trying to imagine how that could be, and I thought of the footy, because I've been watching the grand final today. My voice is going croaky now because of water. Excuse I. And I said, it's like when you go to the footy and you're the first person in the ground. Like, imagine there's going to be 40,000 people at the game. 100,000, because this is Melbourne. And you're the first person in the ground. And imagine that if you, as you walk in the ground, you're the only person in there so far. You're the very first customer, spectator. You walk in, and let's say that this is 20 years from now, and the Illuminati has taken over the world, and you'll get shot unless you sit in a seat. Right. As you walk in, you're a particle walking into the MCG, and as you walk in, and you're going to get shot if you don't. You're going to get vaporized, actually. Nah, you're going to get shot if you don't sit in a seat. So let's just take it as a given. You're going to sit where you're told to. But they did say the seats are not pre-booked. You can sit any seat you want. I think I'm like that photon in that case. So I come into the MCG and I see 100,000 seats. And I say to myself, wow, I can sit in any of those. And I'll say, I wonder which one I'll sit in. And I'm likely to sit on some and less likely to sit on others, because I don't want to sit up high. And I like to be on the wing, So, all right, I'm more likely to sit on some seats than others, okay? But the point is, I will sit on a seat. I'm not going to sit, I'm not going to sit on the floor in between two seats. And I'm not going to sit in between on the ground, you know. So I'll be sitting on a seat somewhere. I'm not going to sit in the aisles either, on the stairs as you walk down to go to your seat. All right, so I walk in, and lo and behold, I didn't have a choice. I had to sit in a seat. Now, the person outside, the bloke who let me in, he doesn't know which seat I've sat in because he's still outside. And he says, that guy, he could be in any of those seats. I don't know which seat he's gone into because I didn't ask him. I wonder which seat he's gone into. And that guy has to actually just satisfy himself with the idea that there is a probability that I could be, you know, every single one of those 100,000 seats, there's a probability that I'm in one of those. And even he knows football. He'll say, yeah, but he's probably on the wing, but I'm not certain. Maybe he was in the mood to hop up in the, you know, up with the bats, you know, up in the, you know, maybe in the nosebleed area, you know, way up high. Or maybe he's behind the goals today. Point is, I could assign a probability to where he's sitting. My position inside the MCG is where I am is kind of a statistical nature. Now, before he even comes in, you know, let's say he doesn't even come in ever. As far as he's concerned, I am in every seat. You know, in one way, shape, or form. And now this is going to be the leap of sort of consciousness here. I am in every single seat in that stadium at once, in a likelihood sense. You know, so he could say to himself, he's the chance of him being on the wing is maybe 2 divided by 100,000. The chance he's behind the goals is maybe 1 divided by 100,000. The chance he's kind of in the forward pocket but up high is maybe 0.5 divided by 100,000. But as I see, he's in every seat in a statistical sense. You know, he's 0.1% chance of being 0.00001. Well, that many, of being in every seat, right? So there's a statistical probability as to where I'm sitting. I'm actually in one way, shape, or form. I'm in every seat. Before, you know, whilst he stays outside. Well, when he comes in, he can see which seat I ended up in. Oh, that's very interesting. Huh. You know, but before he comes in, I'm in every seat, sort of. You know what I mean? Same goes with this photon of light. As it goes through the slit when I shoot it, but I can't see the photographic plate on the other side. I know that now he already knew I was in a seat. He knew I wasn't sitting in an aisle because he knew I was going to get shot if I hopped in an aisle and sat there on the stairs. So when I shoot that electron through that photographic plate, I know it's going to be it's going to actually land like a particle. Boom! Because I'm a particle coming into the MCG. I know it's going to land on one of those lines that makes up a beautiful pattern on that photographic plate. But the electron has landed if I don't look at it, that photographic plate, that electron has landed, has made that entire pattern by itself in my mind. Because there's a you know, if I was going to do they do this, a probability plot, you know. Where did, you know, someone says, where did that photon land? I'll say, I'll draw you a beautiful picture, you know, of all the places it could have landed. And it'll be a beautiful picture because in drawing that picture, I have to not draw on all the spots where it can't be. So someone says, where did that photon go? You've only, one single photon has gone through that thing, that slit. Where has it landed? I'll say, I don't know, but I know that it's on one of these, you know, it's landed on one of these sort of contours, but not in between the contours. So I'll draw you the picture. Actually, before I even shoot the electron gun, I'll get a pencil and I'll draw the picture, and then I'll come back and I'll fire the electron through, and it's going to land on one of the spots on the photographic plate where I drew pencil, and it's not going to land on the other bits. So I know where it landed on that pattern, and I know it didn't land anywhere else. That one electron acts like a wave in as much as, so then I say that electron acted like a wave in as much as, before I look at it, it's landed on a wave pattern. I know that much. So it's like, it knows it's a wave, you know what I mean? But it doesn't. But it knows it's a wave before it even goes through. It knows it's a particle too, because it's only going to land on one spot on that pattern. But it knows it's a wave too, because it knows that it can't land anywhere it wants. And that's a property of something that knows it's a wave. If it knows that it can't land on a trough, if you're thinking of an ocean, and it can only land on a crest, it's a particle because it's only going to land in one spot on that photographic plate. But it's a wave in as much, because at exactly the same time, it knows it can only land on one of the grey lines I drew with a pencil. That was a pretty picture. So it is a wave. Because if it wasn't a wave, it wouldn't have known that it was only allowed to land on one of the spots on the photographic plate that makes a pretty picture. If it wasn't a wave, it wouldn't have been able to do that. But it is a particle because it only landed on one spot, even though it knew what the whole pattern was. So it's a particle in as much as it lands on only one spot on the photographic plate. But it's a wave in as much as it knows where it's allowed to land and where it's not. So it's a particle and a wave at the same time. And I'm home. So I'll finish off there.